Okay. Can you hear me in the back? You can hear me in the back? Okay. You guys can hear me in the back? My voice is shredded. It's not a bad cold, it's just this cough, and I just couldn't talk today. So, uh, you just have to put up with it, and we'll get better, I promise. So, this is Math 270, Calc 1. You should have found this place already. You have you have 3 tasks to take care of before today. Let's just talk quickly through the Blackboard and the syllabus. So over here on the left are the course areas. Syllabus, we'll talk about that in a second. Next one is readings and homework. Okay, after class today, when you go here, the first assignment will pop up there, and that's due Thursday, and it'll give you a full description of what you're doing. Okay, including reading from the text and completing problems. Class videos. So every class period, I'm doing a screen recording of what's on the screen, and then the audio is just the ambient noise in the classroom, which my computer will pick up my voice. So you're going to get a full reproduction of every class in this screen recording, and I will post those as YouTube links here in class videos. So if you go to class videos, Tuesday, January 10th, course intro, there'll be a link there. There'll be a YouTube link. You click on the link, and then you can watch the video class. Now that is by no means a substitute for coming to class. That's for reinforcement, and for going back and watching again, and also note taking. Right. So if you really want to pay attention in class, be tuned in to what's going on, and then you can go back with a video and take much more detailed notes. So don't try to copy every word down and turn your ears off and your brain off. You really want to absorb as much as you can and put off taking notes for later, and you can use the video for that. Okay? So there's some other things here that we'll talk about later. But just for now, that's the most important stuff. So let's talk briefly about the syllabus. Okay, so I am Mark Ashbrook. I'm comfortable. You want to call me Mark, that's fine with me. But anything respectful is fine. The best way to contact me is email. I'm looking at my email all the time, okay? My office is ECA 209. That's right across the street from the bookstore. Monday and Wednesday afternoons, we'll talk about office hours. We actually have a whole spread of office hours throughout the week. There's 6 of us. 6 of us that you can get help for this particular course. And once we get the schedule, I have the schedule, but once we get the locations nailed down, then you'll know that, and you can attend any of those office hours. Okay, I'm gonna just show you that briefly. Okay, so you got Eugene and myself on Mondays, Morgan, Eric, and Julia on Tuesdays and Wednesdays. I'm also on Wednesday, and then Jennifer. So Jennifer's the other instructor for a different lecture. We each have 2 TAs. Teaching basically the same course, so all the students can go to any of these office hours. Okay, you will need support in this course. All right, it's tough. It's going to be difficult, and that's why we're offering you all of these office hours for you to do. Okay, for you to attend. Where am I? Okay. So Morgan is here today. This is Morgan. Some of you will have her for recitation TA. Julia is the other TA. She just had a baby, just in the last week. She had a baby, so she'll be gone for a couple weeks, but people will be filling in for her, and you'll be fine. If Julia's your TA, we have substitutes for her who know what's going on. Morgan will be your TA for everybody for the first couple weeks. Okay, certified calculus genius, Morgan. Okay, she is your best friend in this course. Okay, you've already found Blackboard. You found the text, okay? There's a link in case you haven't. Okay, GC, you should have loaded GC onto your laptop. And then Top Hat, which we'll talk about in a second. Top Hat is our in-class questioning system. So that's all here on the syllabus. Okay, here's an outline of the dates. So this is important. For exams, we will not be taking exams in class. We'll be taking exams in Wexler, 21. Wexler is at the corner of the Palm Walk and Tyler Mall. And it's originally PSA. It's the Physical Science Building. The A Wing is now called Wexler. So it's the PSA. On Wednesday evenings. And the dates and times are set. You know that now, okay? So, first one's the February 1st, then March 1st, March 29th, and April 26th. Okay, so most of you will be able to attend that. If you have a work conflict or another class conflict that's absolutely not changeable, we will make accommodations for you. And we will contact you about that. Don't do that individually, because there's going to be many of you like that. So I will be sending out emails to accommodate people that absolutely can't make it on Wednesday nights. But our exams are on Wednesday nights, and the dates are there, the times are there. So plan your semester schedule accordingly. The final exam, likewise, we know the date and the time. So make your travel plans accordingly. We know that it's the 2nd at 7 p.m., May 2nd. So don't come to me at the end of April and say, oh, I need to take the final early because I'm flying out on the 1st, or I'm flying out the 2nd during the day. You know ahead of time. So make your plans knowing that you'll have to be here Tuesday night, May 2nd. Okay, homework. You can read this all last important stuff about homework, but the one thing I want to emphasize about homework is we'll collect it always right at the beginning of class. 10 minutes after the start of class is the cutoff. If you don't have it, if you happen to be late, you got to be here within 10 minutes. You can turn it in when you come, but after 10 minutes after the start of class, no more homework will be accepted. If you know that you were going to miss class, you can scan it and email it to your TA before class. Okay? Really important thing. So there's too many of you, and it's too hard to organize late homework. So you got to have the homework in at the beginning of class. 10 minutes after class is the cutoff. So what is that? That is 1:40, right? 1:40. Okay, make sure you read this carefully about what homework is, how homework will be handled. But that first, the due date, 10 minutes after class starts on the day it's due. Okay, quizzes. After a week or two here, we're going to start having written quizzes on Thursdays. So the schedule will mostly go like this. You'll have kind of a long homework due every Tuesday, and we'll have a written quiz every Thursday, and that's kind of how the schedule will go for typical weeks. Okay, the rest you can read the fine print. I'm not going to read it to you. Standard stuff for syllabus. Okay. So part of your homework for Thursday will be to study the syllabus for the most important things, and we're going to have a little syllabus quiz. Okay, top out, we're going to do a little syllabus quiz to highlight these most important things that you need to know. Okay, questions about the syllabus, which is right here on Blackboard, syllabus area. Okay, remember again, reading and homework. After class today, the assignment due Thursday will be up. And it'll be, all the details will be there. And then the class videos. Any questions about overview of the course? Okay, so, oh, yes, ma'am.
All of our homework is handed in person.
That's right. In the second half of the course, we may use an online homework system. But for this first part of the course through March, yeah, we're going to be turning in homework. In the beginning, it might be every day, but then we're going to eventually get to just Tuesday. So it'll be amazing. Calculus 1. So I want to kind of give you something of a preparation for your mindset, or something of a warning. Okay? Maybe not that severe, though. Okay, so let's take some perspective. So I want to first talk about math education in the U.S. and in other countries, and an overview of what calculus is and how we will develop it. So first, international comparisons. So in 1975, this was the number of natural science and engineering degrees per 100 24-year-olds in different countries. Okay, back in 1975. So this is gauging in a country the interest and prominence of math and science and engineering um, in different countries at that time. So how's the United States doing in 1975? Pretty good. Okay, we have lots of STEM majors and people pursuing careers in science, technology, engineering. What about in 2000? So in 2000, what was it like? Not so good for the United States. So now we're falling behind internationally in terms of uh, people pursuing careers in science and technology and engineering. Okay, for whatever reason, it's people are shying away from it in the United States, and that's what the trend was. Okay, but now we're so with the internet and in the information age, any company that hires you is going to compete with other countries, right? So hiring is a worldwide phenomenon now, not just nationwide. So you're competing against students who have their education in these other countries: Taiwan, Finland, Lithuania, South Korea, etc. So let's talk about how instruction may have influenced that, what we just saw. So there was a video study called the TIMS. They videotaped 100 randomly selected 8th grade classrooms in Germany, Japan, and the US. Then they made transcripts of those videotapes, and in those transcripts, they took out all national identifiers. And then they had outside people analyze those transcripts. So when they were analyzing the transcripts, they had no idea which country they were looking at in terms of what was happening in terms of reading that transcript of that classroom. They didn't know what country it was from. And so then they did ratings on quality of instruction. And they had criteria for what was high quality instruction, medium quality instruction, low quality instruction. So when all the data was analyzed, Germany came out about a third each in terms of time spent in the class on high quality experiences, medium, and low. Japan did better. Had a lot more high and medium, a lot more time spent in the classroom on high and medium quality instructional experiences for the students. What do you suppose it was in the U.S. from this study? Better or worse than Germany? Much, much worse. This is what the study found. The people analyzing the transcripts didn't know what country when they looked at the transcript of a classroom. They didn't know which one it was, and everyone analyzed them, and this is the way it came out. So what do you suppose? What kinds of things would qualify as high quality instruction versus low quality instruction? So what do you suppose those categories consisted of in terms of things in the classroom? Any ideas? What's that? What do you think they meant by high quality instruction? What kind of criteria? What were they looking for that would be classified as high versus classified as low? Yeah. Okay, students participating. Yeah. Okay, student interaction. Yeah. No, this was 8th grade math classrooms. This was 8th grade math classrooms. Yeah. Okay, yeah, he really hit the nail on the head there. So, high quality instruction was experiences where students were really coming to understand content. Low quality instruction was, and he said the word memorization, okay, or just replicating procedures, right? Anyone been in a math class like that where it was the teacher did an example and then you were expected just to replicate those examples? Yeah, so I know it's and this was in 2000, but it's still very prevalent today in the United States. This focus on procedures. Show me how to do it, and then I'll just do it like you just did it with different numbers. Okay, so in 2000 and still applies today, we're falling behind our international counterparts in terms of the quality of math and instruction. And this could be a big reason why a lot fewer of us are going into technology, engineering, mathematics type careers. Okay, so what is calculus? Is it just a bunch of complicated procedures? Why do that if you have Wolfram Alpha? Do you guys know what Wolfram Alpha is? Yeah, it's a really, really powerful resource. It's not something you have to, be quiet about and say, shh, don't tell your teacher about this. This is a really powerful resource for doing complex computations in a snap. Okay, and that's a good thing. Let's use that. Let's use that to our advantage. Okay. Same with So here's a integral problem. You hit enter. You put this integral problem in. It's a calculus problem. It gives you a graph. It gives you other information. It tells you all kinds of things about whatever you enter in. Okay, in this case, an integral. GC. GC is a really, really powerful calculator. Here's a complicated derivative, x to the 3 to the x, which would take several minutes doing it by hand. You just hit enter, and it gives you the symbolic answer to that question in less than a second. Okay? So if we have this technology to do this, then let's use it, and let's use it appropriately. Okay? Let's not pretend that it's not there and do all this stuff, take hours and hours doing things by hand that technology could do in a second. So, but historically that was the case. People learned calculus to get jobs that required lots of computing. They had to be super fast at performing the procedures flawlessly because we didn't have the technology to do it. Okay? They were given functions and equations. People's jobs was to do with them what they were told. Okay? But today, computers can do these procedures of calculus far more quickly, far more accurately than a human. But computers cannot decide what function to analyze or what equation to solve. A human must decide these things in order to tell the computer to do them. So the users of calculus today are more like managers of yesterday. Okay? So that's what we want to become. We want to become managers. We must understand what we're doing and be able to explain why we're doing it. Okay? That's what we're after. Okay? So what are your past experiences in calculus and pre-calculus? When you worked with some symbols and performed computations, to what extent did you understand all that it represented? So that's going to be varying degrees with some of you. Some of you maybe didn't understand much at all. Others more. So this class is about developing an expert knowledge of calculus so that you can figure things out, not just remember what to do. So we want you to become problem solvers. Okay? So if something I present, so some of you have had calculus before. Don't try to anticipate where I'm going. Pretend you haven't had calculus before. It's actually, for some of you having calculus before, it's going to be a detriment in this class because we're handling it so differently. We're looking at it so differently. So don't try to anticipate because then you have the tendency to turn your brain off. Okay? Pretend you've never seen it before, always. And stay with the progression of things that we're doing and always learn with understanding and meaning. Okay, so what this class is not about: rote memorization, replicating examples and procedures, doing without thinking to get answers, guessing what I want you to say or what the TAs want you to say. Okay? And many of you have had experiences like this in math classes in the past. So what is this class about? Using your own capacity to think, to understand the ideas, develop insight into the world of quantities and relationships. Okay? See ideas coming as groups. There's no such thing as an isolated idea. So this course is going to be like a journey. It's not going to be chapter 1, learn how to do these problems. Chapter 2, learn how to do these problems. Chapter 3, learn how to do these problems. We have a journey that we're going on. Okay? We have a journey that we're going on. Everything that we focus on is going to be important later on. and this journey is an endeavor to of coherence of all ideas in order to arrive and understand the fundamental theorem of calculus. Okay, so everything that we choose to do here at the beginning and along the way is all about coming to this understanding of the fundamental theorem of calculus. It's not isolated topics at all. Okay. All right. So when tackling problems in this course, this is a common reaction you're going to have. He never did one of these before. Okay? And so then emotions come into this, right? Emotions come into this. And so we got to channel that energy into a positive instead of negatively, okay? So, yes, we're going to give you problems that are unlike ones you've seen before, but we've given you the tools to work at it and make progress and to figure it out, okay? So we're going to rely on our understanding to solve rather than a previous example, okay? We want to bring together multiple ideas. So a new problem that you've never seen before. It may take a little bit of this idea over here, and a little bit of this idea over here, and a little bit of this idea over here. Put them together to come up with a solution. All right, and then we're going to take our knowledge and transfer to new situations. And then we want to be able to write coherently about our thinking. Okay, but this is the real test to see if you really understand it. If you can write and explain correctly what you're thinking. Okay, so there's only one way to improve in problem-solving skills, and that's to be regularly engaging in new problems. Problem solving is about coming to something novel, something you've never seen before. You're not going to get better at that unless you do it. And so it can be frustrating, and it can raise some negative emotions, but you just have to know that we have your best interest in mind. We want you to be independent, unique, or good thinkers, and be able to problem solve and really understand calculus and be able to use it effectively. Okay, and when you come for help, expect guidance and questions posed back at you to help you figure it out. Okay, so the worst kind of tutoring is someone that takes your notebook and then just does here I'll show you, and just does the problem. Okay, we'll never do that. We'll always ask you what your thinking is, where you've been, or how much progress you've made in the problem, just to understand where you're at, to meet you where you're at, and then give you hints to continue forward from there. Okay, so here's a tale of two students of mine in the past. Student number one. Rate my professors. Rate my professors. He's honestly a terrible teacher. Nice person. Thanks. But tries to teach the why, forgets about the how. It really kills your grade. I've never had below 95 in math class, and now I'm hoping to get an 88. Okay? So, this is not an uncommon reaction. Okay? But in light of what we're talking about, I would guess, that most likely to this student, what is a good teacher to this student? A good teacher is one that demonstrates and explains complicated procedures really well and then assigns grades based on students' ability to mimic them. That's the mindset the student has. And when you have that mindset in this class, this is going to be a reaction. This teacher is terrible. He's not showing me how to do the problems. Okay? So the whole point of this little lecturette here is you need to have the right mindset coming into this class. It's going to be different than math classes you've had in the past. Okay? But this is the kind of instruction that so many of you may be expecting. It's the kind of instruction that's put us far behind other countries in mathematics ability, right? Now we're in the middle or towards the bottom in terms internationally. Okay? So we need to do better. So this course is one small attempt to do better at that. Okay? To do better at that, to give you the skills to compete internationally. Okay? Student number 2. This is an email I received. For the first 4 weeks of class, I left every day feeling that my brain had been mauled into abstract obscurity. Now I was actually helping my friend from another college with her Calc 1 homework. She was amazed at how much I knew. And even though all of our language was different, I was able to teach her about why each piece works and what it's there for. I've also been helping people at my table. It is so satisfying to have these daily aha moments finally. Okay? So what does this tell me? It tells me that you can make a journey from an old mindset for math classes to this new mindset that's going to allow you to succeed in this class. But you just have to be willing, and it's gonna take patience and hard work. Okay. So the moral conclusion: good math instruction in U.S. is not good by international standards. Don't expect this class to reflect your experience in prior math classes you've had. Okay, it's gonna be different. It's gonna be different, and to many of you, that will feel harder. Okay. But meaningful learning requires hard work. It takes patience, perseverance, and help. So you're gonna need the support. That's why we have all those office hours all week or throughout the week. Okay. But the benefits are great. Okay. Having real understanding, having the tools to be able to solve problems, not just be able to do things that you've memorized. Okay. To really know what calculus is and know how to use it. Okay. All right. By the way, this is my grade distribution, letter grades last semester, 132 Calc 1 students. So this person's saying it really kills his grade. He's thinking that his grade is based on his ability to mimic procedures. That's not what we're about. We want you to show us that you understand things. And lots of people, like I said, in this course have been able to have this evolution of their thinking and their approach to the math class. Okay, that allows you to succeed in this class. Okay. Any questions? All right, so plenty of people doing really well. Also, plenty of people not doing so well. So it's not just a cakewalk. Okay. Any questions about this? Have I gotten your attention in terms of it's going to be different, and it's going to take patience and hard work, and there may be some frustration along the way, but just don't give up. Keep trying. Come to office hours. Get the help that you need. Okay. So that's that. You guys are quiet. Let's do some math. So you read some about large and small quantities. If you have your laptop and you want to get out GC, some of you had recitation yesterday, and you started working in GC. Is that right? Those who recitation yesterday, you opened up GC, you started working with it. Okay, if you haven't, so when you open GC, you should get a window like this. Okay, when there's a little colored box there, that's a mathematical command line. Although it's not a computing language. Okay. The great thing about GC is you just enter in mathematical statements, exactly like the types of mathematical statements that we're going to be learning in this course. It will interpret them, and then if there's a graph involved, it will plot that mathematical statement visually. Okay. So if there's a little colored block, then that's where you're going to enter in mathematics. If you do Command T, and on PC, what is it for text? Do you guys know? Control T. Either Command T on Mac or Control T. This is for just text. This is for your own use. So you can type to organize your work or take notes. So those are the two basic types of lines. Just text line, where it's not GC doesn't pay attention to that at all. That's just for your use, taking notes, organizing your work, and then there's these mathematical command lines. So before we get into any graphing, just know that GC itself is just a powerful arithmetic calculator. So you can just put things in like 20 plus so 20 plus 3. To do squared, you can just do shift 2. That does squared. Minus. To do cubed, you can do shift 3. With any other exponent, you're going to need to do shift 6, do the caret first. So say I want to do that whole thing raised to the, oh, and then parentheses. You could highlight that whole thing, and then all you need is the left parentheses, and it will put the full parentheses around it. So to get parentheses, all you need is just the left parentheses, shift 9. Shift 9, that gets a whole set of parentheses. And maybe we want to raise that to the 1/3. So with square and cube, you can do shift 2, shift 3, but any other exponent, you need the caret, shift 6. And then notice that as I was making this, it was always telling me what the current value was, right? So if I take off the 1/3 power there, this is negative 314. I can come in here and change the exponent, 7 cubed. Maybe I want square root of 7. So square root, you could do caret 1/2 power, or you could do control or command V, no, option V. So on Mac, square root is option V. And what is it on PC? Control shift S, maybe? Anyone got a PC? Control, what is square root? Do you know what square root on PC is? Control shift R. Is that what it is? Control shift R is square root on a PC. Okay, so you can copy and paste. So I could take that, I could copy that. To start a new command line, it's either control return on a PC or command return on Mac. Command return. So then I could paste. You just copy and paste previous things you've done. And as you edit the expression, the answer is always updated. Okay, so I can do divide by 350 minus. Okay, and then pi and e. So to get pi, you just hit pi. Pi, and then it makes it pi. So it's a really nice, because you have all the copy, paste, and editing right there in front of you, and then it'll just always give you the current value over here of the expression. Any questions just about this basic calculations? Talk about square root, powers, and then you can, again, you can highlight. So if I highlight this whole thing and then do option V, it'll square root that whole thing. So you can use highlighting like a word processor also, okay? Or you can highlight and hit Control 9, and it'll put parentheses around whatever you've highlighted. Okay, so let's look at some examples here. You don't have to recreate this, okay? You could just, if you want to clear out what you've done so far, let's do some problems regarding large and small quantities here, okay? So the speed of light is this number here, 299 million meters per second. Distance from Earth to the Sun. We got 3.28 feet in 1 meter. So some conversions there. So that's all text. And this black box is my first line. And so what I want to put in here is I want to write a calculation. Okay. I don't want to do any simplifying. I want to see the whole calculation that solves this question. how many hours would it take for a pulse of light from the sun to reach Pluto, which is 3.6 billion miles from the sun? Okay, so why don't you take a minute and work on that, see how you do. And then what I'll do in a minute is I'll put up my solution and I'll have you analyze my solution because there's different ways to do this. Miles. Yep. Yeah, so you got some conversions to do. So give this problem a shot. See what you come up with. Okay, whenever we put you to work in class, you definitely want to take time to think about it, but then you're always encouraged to collaborate with the people around you. Okay? Always, unless we say otherwise. So yeah, take the time you need to think about it for yourself, but work with the people around you. And so before you start, that being said, we're gonna have a sign for in order for attendance in lecture. We're gonna take attendance. The TAs are gonna take attendance. We're gonna have a seating chart. Okay, but you're gonna make it, not us. So on Thursday, you want to find the place that's gonna be your home. Okay, this semester. All right. So find it, and then if you're in Morgan's, what days are your recitation? Both of them. So if you, okay, so Tuesday recitations are with Morgan. If you're in Tuesday recitation, you're going to sit on this side of the classroom. And then the other one are Julia's recitations? Mondays? All Mondays? Thursday? Okay, so if you're not in the Tuesday recitation, that means you're Monday or Thursday, I think. You're going to sit on this side. That's Julia's student, and these are a couple weeks. Okay, so when you come on Thursday, you're going to find your home where you want to sit for the semester. We're going to create a seating chart, and that's how it'll help us to take attendance while we're learning your names. Okay? Okay, so you're working on just problem one, okay? You can't do two yet, right? You can't do two yet. So just working on number one. So like I said, there's lots of ways to approach this. You may have something different, but here's how I started. Okay, I took this 299 million number and I multiplied by 3.28. Okay, so all I want you to do is figure out what does that do? What's the result? What's the meaning of the value you get? This 9.8 times 10 to the 8th, or that expression in the parentheses. What's the meaning of that? And then does everyone know? It's E plus 08. We need to be real sure we know what that's about. And that was in the reading. Right? What does that mean? That's scientific notation. It allows us to express really, really large and really, really small numbers, right? So this is times 10 to the 8th, okay? That's what that E plus 08 means. So what does this number, 9.83319 times 10 to the 8th, what's the meaning of that? So that's kind of like my first step toward answering this question. What's the meaning of that? Okay, so I want everyone to introduce yourself to the person next to you, and we're all going to be talking with somebody. Compare your progress so far, and then talk about this. What does that mean? Okay, I just updated that. So now there's two sets of parentheses. For every set of parentheses, you should be able to identify what's the meaning of that number. So there was the original one. Hopefully you talked about that. Now I've updated it. I've added another thing here. I divided by 5,280. So now this whole set of parentheses, what does that mean? What does that mean? Keep going. So now I started a new command line. And I took 3.6 times 10 to the 9th and divided it by that thing that we had before. What would this mean? What would this mean? Talk. What should I do now? Okay. So this was, what is this? How many seconds it's going to take for the light? So I'll talk through the whole thing in a second. So if this is the number of seconds, then how would I get, what do I want? What the number of hours? Right. Okay, so there's 3,600 or 60 squared seconds in an hour. So we want to know how many 3,600 chunks of seconds fit into that, right? So we want to know how many, that's a bunch of seconds. How many 3,600 seconds fit into that? So what do we do? Divide it by 600. Okay, so I got about 5.5 hours. Let's talk through the whole thing. Here we go. Every set of parentheses has meaning. So we're kind of want you to try this new way. So I want to discourage the unit analysis because unit analysis it doesn't really force you to think about what's going on. Okay. Here is our what? This is our speed of light in meters per second. If every meter is 3.28 feet, then this first set of parentheses is what telling us how many feet light travels every second, right? If it travels that many meters every second, and there's 3.28 feet per meter, then there's going to be 3.28 times as many feet that it travels in a second than meters. So this is how many feet light travels in a second. If we want to know how many miles it travels in a second, then we want to figure out how many groups of 5,280 feet fit into that number of feet, right? So how many 5,280s make up that number of feet or fit into that number of feet? So that's division. So then this is going to tell us now how many miles it travels in a second. And then what do we do next? We said, well, we got this total number of miles. So we want to know how many of those groups of that many miles would fit into the distance from Sun to Pluto. So this is the total distance from Sun to Pluto. And this is a certain number of miles. How many of these number of miles would fit into that number of miles between Pluto and the Sun? And that's going to be the same as the number of seconds because every mile here is 1 second. This is the number of miles that corresponds to 1 second of travel, right? 1 second of travel. So we want to know, we want to find out how many miles, how many of this number of miles goes into that total distance. That's going to be the same as the number of seconds to cover that distance. So that gives us the seconds. And then finally, we're going to divide out by 3,600. We're going to find out how many groups of 3,600 seconds go into that number of seconds. Will be the same as the number of hours. Okay, questions. Like I said, there's other ways to do it. But we want to, if this is a new way for you to do it, I want to practice that. Okay, building it one step at a time and really understanding the meaning of every set of parentheses. Okay. Questions on that? Yeah. So you have Mac or PC? So PC, is it Control T? Do Control T, and then it'll open up. Yeah, and then Control Return then gives you another math line. Yeah, sure. Other questions?
If you're in the menu box, so like if you hit text at the very top in the menu bar, in the toolbar, at the very top, see text is
Yeah.
there, and then see there's a new text block, the shortcut is right here.
Yeah, so yeah, there's the keyboard commands, or you can find it in the menus too. Okay, questions on that example? All right, let's do this. We need to have movie mode. Oh, shoot. Is there movie mode here? Movie. All right.
weighing it, I figured one bill of any denomination weighs a gram. There are 454 grams to a pound, but there's a variety of denominations. So, how much is this? I have no earthly idea. I truly don't. I just stack it up, keep it dry, spray it for silverfish. There is more money here than we could spend in 10 lifetimes. I certainly can't launder it. Not with 100 car washes.
Okay. So some of you know what that's about. How he got that money. Let's see here. Presentation. No. There we go. Okay. So we want to know. So he asked, "How much is that? How much is that?" She said, "I have no earthly idea. More than we could spend in 10 lifetimes or launder through 100 car washes." Okay. So let's try to figure out how much money that is. Okay. There we go. Okay. So maybe this is, I'm going to estimate this to be about 6 feet this way. Okay. 3.5 feet this way. And 2 feet high. And we're going to suppose that it's all $50 bills. It's all 50s. Okay. All 50s. 6 by 3.5 feet by 2 feet. And we want to know, how much money is this? How much money is this? All right, so the dimensions, so I'll give you some info here. The dimensions of a bill are, this is in centimeters, 15.5 by 6.6 by 0.01 centimeters is the dimensions of a bill. We want the total amount of money in the block. If it's $50 bills, and the block measures 6 by 3.5 by 2. Okay? Try to use this approach that we were doing, where you work with nested parentheses, and you always know the meaning of each set of parentheses as you work your way out. Okay? There will be different approaches, but see if you can do it kind of in that fashion. And Morgan and I can help you. But again, take your time to think about it, but then work together. We encourage you to work together always. Oh, yeah, sorry. Okay. I put the conversions up there. here's the thing about GC. Between text lines and the math lines that are editable, you really don't need pen and paper. You can do everything right there in a window on GC. If you're making good progress, keep going. Or you can look at what I've started to do here and again, analyze each set of parentheses for the meaning of the number that you get in each set of parentheses. Again, there's maybe a dozen different ways to approach this. This is one way. But it's good practice to look at somebody else's and say, what does each set of parentheses mean? Okay? Yeah, definitely do that. So do it now before we go on so we don't lose it. But yes, save your files as you make them because you can use them again. Okay, so here I'm saying how many sets of 3.28 feet fit into 6 feet. Okay, that's going to tell me how many meters that is. 6 feet, right? That's going to tell me how many meters 6 feet is if I'm looking at how many groups of 3.28 or how many meters fit into 6 feet. Same with the 3.5 and the 2. So then this numerator is finding what? What is that numerator finding? That's going to be cubic meters of the block, right? Cubic meters of the block. Then I came down here and I looked at these, and I know to get the dimensions of a bill in meters, 15 centimeters is going to be some fraction of a meter, right? So we know that there's 100 centimeters in a meter. So the fraction that 15 is of 100 is 0.155956. That's how many meters long a bill is. And then this is the width of a bill in meters, and then the thickness of a bill in meters. So that denominator is the volume of a bill. So we're asking how many of these volumes in meters cubed fit into this big block in meters cubed. So that whole thing then tells me what? How many bills in the stack, right? So how many of this volume fit into the whole big stack? That's how many bills. So to get the money then, times 50. So what is that? The seventh. 52 million? $52.7 million. Is it a lot of money? Is that a lot of money? $52 million? Is it a little bit of money? Or a lot of money? $52 million. Is it a little money or a lot of money? It depends, right? It depends. And that's the next big theme. You're reading for Thursday, you're going to read about that, and you're doing more problems like we just did. But when you look at the national debt, 52 million is a drop in the bucket, or half a drop, okay? See you Thursday. Remember, homework's on Blackboard.